who it may concern. My name is Liam, and welcome to my lab report. I'm going to be doing 2 experiments today. One focused on buoyancy, and one focused on flow rate involving tubes. As any good experiment, I'm going to need to gather some supplies. The first thing I need is a dense object. This will have to do for now. Now we gotta fill a pan with water to test this experiment. Let's time lapse this, what do you say? Ah, perfect. Now to get this to the table. Damn, pretty heavy. Oh. Well, anyways, as you can see, the can kind of floats, but not really. It's mostly underwater. Anyways, now we need a less dense object to test if it's buoyant or not. Let's throw it in, see if it floats. Hey, look at that, and it does. So, the serious science behind this is this equation, FB equals PGV, where when we multiply the density of the fluid versus the gravitational acceleration and the volume of the fluid that is displaced, which we measure by how much would flow over the top of the pot, we can figure out the buoyancy force. And if the buoyancy force is greater than the weight force, we know it'll float. So when the dense can buoyancy force is less than the weight of the can full of beer, so it'll sink, while as the empty can is obviously a lot less heavy, so it'll float. The next experiment I'm going to do is a flow rate experiment, so I need to make a small hole in this can to resemble a tube. I'm going to make a bigger hole later and compare the flow rates. Alright, the next step is to drown this can and fill it up with water and test how long it takes to flow out the hole. I'd say they took about like 10 seconds. Now that we tested that gauge hole, I'm going to need a tool to make it larger. Hopefully emptying this can didn't impair me too much. Now that we've made a bigger hole, let's test the flow rate. I'd say that was significantly faster. What a mess, in the name of science. So the science behind the flow rate experiment is as follows. So we have this equation, and it depends on the size of the hole, like the radius of the hole it's flowing through, and the density of the liquid. And since water is like the same density, in that experiment it only depended on the size of the hole. And so when the hole got bigger, a lot less pressure was in the can, and it flowed out a lot faster. Thanks for coming to my lab report. Bye bye.